Hello. Today we are going to be talking about numerical integration 3. So first off, quick review, as always. There are two types of integrals: definite integrals, which have factors of integration, like so, or indefinite integrals, which have no factors. Definite integrals will always result in a number, and that number is the area under the curve of the integral, or the function. Indefinite integrals always result in the formula. Now, from last time, we proved that for the sum of any n numbers, it can be calculated as n times n plus 1 over 2. For the sum of any n squared numbers, so 1 squared, 2 squared, 3 squared, all the way to n squared, it can be represented as 2n plus 1 over 3 times n plus 1 over 2. And for cubes, 1 cubed, 2 cubed, 3 cubed, all the way to n cubed, can be represented as 1 or n times n plus 1 over 2 squared. Next, let's do a quick example. So if we consider f of x equals x, also known as the identity function, any number we put in, we also get out. So if we put in 5, we get 5. We put in, 7, we get 7, so on. So it can also be said that f of x over n is equal to x over n. So we're going to be using that. So we're going to draw a quick graph here. And we're going to divvy up the line into ninths. Actually, those would be tenths, I think. But each line is a ninth of the graph. So 4 ninths, 5 ninths, 6 ninths, 7 ninths, 8 ninths, and 9 ninths is one. Let's assume this is function f of x. Now we can figure out what the area under this is. We could solve it as an integral from 0 to 1. The integral of 0 to 1 f of x dx. We can approximate what that is by taking the area of these squares right here. Oh, I missed this one. What? Yeah, we could area that. So if we do the first one, it's going to be f of 1 ninth times 1 ninth. The next one, it'd be f 1 ninth, or 2 ninths times 1 ninth, so on until f 9 over 9 ninths times 1 ninth. Now we can use this to prove a theory. Now if we have the same problem, we can write this as the integral of 0 to 1 f of x dx, limit n to infinity, n k to n, or sorry, k to 1, my bad. Or would it be k to n? I think it's k to n, f k over n, 1 over n. We can simplify this to the limit of n to infinity. En k minus 1, or would it still be, or k to n, k over n times 1 over n. We could simplify this even further by taking the n's and moving them out. So we can have the limit of n to infinity k to n 1 over n squared k. Now we can turn all of this pretty much into the limit of n to infinity, 1 over n squared, 1 plus, and then the sum of n numbers, which, as we know, can be swapped with n times n plus 1 over 2. So let's do that. Infinity, 1 over n squared, n times n plus 1 over 2. Let's get out a new page here. This. So then we have equals 1/2. We're going to bring out the 2 from the bottom. Limit of n to infinity. 1 over n squared times n squared plus n. We can simplify this even more by combining these two. So we have 1/2 limit of n to infinity, n squared over n squared plus n over n squared. We can simplify this as n if 1, so we can do 1/2 limit n to infinity. We can simplify this to 1 plus 1 over n, which we could simplify even more to 1 plus 0, which is 1/2. Thank you very much for watching this video. Bye.